Good afternoon, my students. How are you? I hope that you'll be okay and your family also okay. I hope you stay in your home. Today we need to talk about our topics that we need to complete also our topics that we finished before closing the schools. So we need to complete our topics with you, Mr. Chadi Eldib from Tabarak Private Schools.
Good morning, my students. How are you? I hope you'll be fine. Today we need to talk about the second topic in our chapter. This second topic in our chapter, its name is photoelectric effect. This topic is very important topic. You will find it. This topic it's full of some equations, and also this topics it's full of some questions and problems. So you have to concentrate about this part, especially. It's very important. So today we need to continue this second topic, photoelectric effect. Okay, now we need to know what's meant by photoelectric effect. Photoelectric effect. When we need to know what's the definition of the photoelectric effect, we'll find that this word photoelectric. Look at this photoelectric. It consists of two sections. Two sections. Number one is known as photo, and the second one is known as electric. So what's this photoelectric? Photo comes from light, but electric comes from electric current. So photoelectric, maybe we can guess that the light converted to electric current. Maybe, we don't know. So we'll check, is it like this or not? One of the famous force scientists, his name is Hertz, who discovered this photoelectric effect, and he said that this phenomena, it's a very important phenomenon. What's the definition of photoelectric effect? He said, when light shines on a metal, when light shines on a metal, electrons can be ejected from the surface of the metal in a phenomena known as the photoelectric effect. As I told you that when the word photo means light, so when the light incident on a metal, when the light incident on the metal, we'll find that this light that incident on the metal try to eject electrons from the surface of this metal. This phenomena is known as photoelectric effect. This process is also often referred to a photoemission. Photoemission, and the electrons that are what? And the electrons that are ejected from this metal are called photoelectrons. Why we said photoelectrons? Because these electrons that eject from this metal comes from light, because of light, okay, comes from the metal because of the light that shines on this metal. So photoelectric effect may be coming in final exam, define photoelectric effect. So we can say that when light shines on a metal, electrons can be ejected from the surface of the metal. Okay, and look at the diagram. You will find that this red wave that incident on the piece of metal, and inside this piece of metal we have some electrons. So the electrons ejected from this metal. This diagram represents the process of photoelectric effect. Now we need to explain why these electrons eject from the metal. What are the conditions? What did the light do when it incident on this metal? Einstein gave us an explanation for this, and he assumed that the radiation itself consisted of packets of energy, bundle of energy, as we explained it in last video. Okay, packets of energy. This packets of energy, a bundle of energy, E equals hf. Did you remember this Planck's equation? E equals hf, and we said that h is a Planck constant, which said this, or which are now called photons. Did you remember this? Which are called photons. The energy of the photon could be calculated using Planck's equation. E of photon equals hf. So Einstein said that any radiation consists of bundles of energy, or consists of photons. The energy of each photon is E equals hf. Now we can think of the incident light as a stream of photons. think that the light not consists of one photon, more than one photon. It means consists of photons with an energy determined by the light frequency. When a photon hits the metal of the surface, or the surface of the metal, when the photon hits the metal surface, the photon's energy is absorbed by an electron. Look at this. When the photon incident on the metal, we'll find that the electron that founded in the surface of the metal absorb this photon, because we know that radiation consists of photons. Absorb this photon. Then what happens? When it absorbs this photon, it ejects. The graphic below illustrates the relation between light frequency and the kinetic energy of the ejected electron. We'll see this graph after that, inshallah. So the scientists observed that if the incident light had a frequency less than a minimum frequency, FO. What's FO? FO is known as threshold frequency. And this threshold frequency, it's a frequency related to each metal. If the metal that we have it is made of copper, is made of zinc, is made of potassium, each metal, its atoms or its molecules or its electrons inside it vibrates with frequency. This frequency is known as threshold frequency, and it's constant for each metal. So Einstein said, if the frequency of the incident light is less than the minimum frequency or threshold frequency, sure 100% no ejection for electrons. But if the value of FO equals to the frequency of the incident light, directly electrons eject. But if it's furthermore, what's meant by furthermore? If the frequency of the incident light is greater than what? Greater than this FO threshold frequency, it means the electrons eject from the metal, plus that we have a kinetic energy Ke. So Einstein put this relation in an equation. E of photon equals Ke of electrons plus phi. What's phi? Phi is the work function. What's work function? Work function is the energy. Work function is the energy of the energy of the metal. The energy of the metal, or we can define it because in final exam maybe asking you define work function. Work function phi is the smallest energy needed to eject the electrons from the metal. The smallest energy needed to eject the electrons from the metal. It means the metal has energy. Its energy phi equals HFO. Be careful, you have to differentiate between, not to be confused. You have to differentiate between what? E equals HF and phi equals HFO. Make a differentiation between both of them. E equal HF means the energy of the photon that incident on the metal. But phi equals HFO, this is the work function of the metal. Work function of the metal, phi equals HF and HFO, and FO is the threshold frequency. Take care, threshold frequency. And I told you, if the incident light had or has a frequency F and it's less than FO, it means no ejection for the electrons from the metal. But if the frequency is greater than, we have ejection and kinetic energy. Kinetic energy means the electrons eject and now move fast with a kinetic energy. But if F equals to FO, no ejection for the electrons. If the F frequency equals FO, it means we have ejection but not having a kinetic energy of the electrons. So take care. Now we can say by another way, not by using frequency, we can say by energy. If the energy of the incident photon greater than work function, so we have ejection plus that we have kinetic energy. But if the energy equals to the work function, we have ejection only. If the energy less than work function, no ejection for the electron. Look at this photoelectric effect graphs. We'll find when we draw the graph between Ke maximum and frequency, we'll find that we have different metals. Look at this. This is metal 1 and this is metal 2. And what's this? This is the relation between Ke and F. Why it looks like this? It looks like this because look at the equation as we said it before. The equation said that E equals phi plus Ke. This is remember to this is or looks like something you have to remember it or memorize it. It's the linear equation, and we have in linear equation y equal 5x plus or ax plus c. Did you remember this equation? Y equal ax plus c, and you know that this c means intercept of y axis. So look at the equation. We'll find that here this fc1 means if threshold frequency. Also here fo threshold frequency and the intercept of y-axis means phi. Look at this phi the work function. The intercept of y-axis equals work function, and the gradient of this graph equals h, Planck's constant. So we have to study this graph very well, because this graph maybe comes in or maybe came in a graph like this with values and asking you what's the gradient of this graph. You have to calculate it h, and h equals delta y over delta x, and in this case you have to choose 2 points, y2 minus y1 over x2 minus x1. So please, you have to revise all of this, and we'll continue in the third or on the third videos inshallah after that.
Thank you for your listening, and also thank you for your caring for what we explained, and thanks also for the chairman of our school, Mr. Yunus Rahbi, because he did everything related to make this process very cooperative, related to new technology in education and how to process this technology to reach all information to the students. So thank you, and don't forget that the homework also uploaded in model in the website of our school.